Ready to move on, Don? Thank you, Don and Dimitri. I enjoyed that. I appreciate it. I appreciate all of those that contribute content. Speaking of whom, a frequent contributor of content who needs no introduction, so I won't provide one. He'll introduce himself, as is our custom. On with the show, Brad.
All right. Can you see that?
I can.
All right. This talk is probably almost 40 years and it has a genesis in something that I experienced almost 40 years ago. It involves the great granddaddy of all the of our contemporary desktops, the original IBM PC. I had occasion to encounter one when I'm not exactly sure how old I was. It was probably 8 or 9 thereabouts, and I actually remember the first program, or at least one of the first programs that I tried on that system, and I distinctly recall it because unlike other systems that I'd interacted with, it was the first I'd encountered that had a circle drawing operation in the BASIC, and so I wrote a program something like this that drew this, and it would, obviously run slowly, so it would sort of blow up like a balloon. It was an interesting thing. And back in those days, when you bought a computer, it came with a bunch of manuals, and they were usually very specific and often had a lot of specific detail. And this was the manual that was associated with the BASIC for the original IBM PC. And as one did back then, you would pore over these manuals because, in times before the internet, this was your source of information. And so I remember at length poring over the manual for this thing and coming across the out operation, which relates to the on the x86 system. There are sort of two buses. There's the main memory bus, and then there's a separate range of ports that you can send operations to. And a lot of hardware will use this for configuration registers and so on. And as I leaf through this, there's some operations in here that describe writing to particular ports to manipulate different aspects of the display. And then if you flip all the way in the back to Appendix I, there's some technical information and tips. And in particular, there is the option to toggle a setting, whether or not you use blinking text or you used all 16 colors in the text mode for the background color. And I undoubtedly at the time played around with this and found this fascinating. For those that don't recall, there was sort of two modes of operation. You can either have the fourth or the third bit 3 for the background color cause characters to blink, or you can have it boost the intensity. But then I remember something very distinct occurred to me to do, which stuck with me to this day because it was a surprising thing and probably one of my first experiences sort of poking at something and learning something by an indirect means. I got the idea of, well, what would happen if I did that operation? It said this particular out operation was something to be used in the text mode. Well, what would happen if you did it in the graphics mode? And I recall doing this, and then something surprising and kind of amazing happened. I got something like this, and this sort of was a little confusing to me, but because it was in sort of similar color scheme to the mode was not sort of like, what's going on here? And you would see these sort of gobbledygook characters, and sort of I wondered what was going on. I probably might have rebooted the machine or something to get out of this weird state that was in. And so then I probably tried it in screen 2. And then I got an even more sort of interesting result, because it involved an awful lot of colors on the screen, especially for a system that had some very limited colors in graphics mode. And so I recall at the time wondering what was going on, and I believe I may have even had access to some of the technical reference manuals that I think at the time I partially understood that what was happening here was that I was seeing the text mode, but with only some portion of the graphic characters, the tops of the graphic characters being displayed. And so years later, I came to understand that I had stumbled upon some of the peculiar and interesting capabilities of the CGA card, but at the time, as this was a machine that I didn't have regular access to, I didn't experiment too deeply with it, but it always stuck with me. So let's talk about CGA. So CGA was the first color graphics adapter for the IBM PC. It used a Motorola 6845 display controller to generate a display, and it had 16K of RAM that was actually on the display adapter board, and it could do either RGB plus intensity output to like a digital pinned monitor, or composite output. This is the board, and if you can see the 6845 right there in the middle, there's a whole bunch of 7400 TTL around it, and then down at the bottom is each of the 16 single bit RAM chips. So there's sort of eight of them to give you an 8-bit 16K RAM on the thing, and so it's a fascinating board. It was sort of IBM's first foray, and at least sort of in terms of the documented modes, it supports an 80 by 25 16 color text mode, a 40 by 25 16 color text mode, and then 2 graphics modes, one that has 4 colors and one that has only a single color. And that 4-color mode is sort of interesting in that it does give you some flexibility to choose a palette, but it's actually a fairly limited set of palettes. And you do have also the option to change the bottom. You can change the 0th color to be any of the 15 colors. But since that's the black in the palette, it's actually not. It's sort of in some ways not a particularly useful one to change. From BASIC, I do recall that there was only access to the first 4 of these palettes, and you actually end up being in a slightly different mode in order to get the palette with cyan and red, or at different intensity levels. And so that one you had to go poking about with the register set of the machine to get to. For some reason, they didn't expose that in BASIC. And as folks who remember the era, probably distinctly recall, these are some pretty ugly palettes. And so, there were a lot of the games of this era had a very particular look because, this is a really strange set of choices. And I'm sure for a machine targeted at businesses that were, you wanted to be serious or whatnot, maybe these were sensible high contrast colors, but, and so each of the different palette options, some game or other, used in that era, and people sort of lived within the confines of it, and some games sort of discovered that they could do this slightly better. Red and cyan have a complementary color thing going on that's at least a little bit more of a sane contrast, and so some folks did use this. I remember this Ford actually published a driving simulator where you could notionally try some of their car models, and I don't know why you would want to try that with a keyboard and whatever, but so there were a few things that used the background color. It was more rare. Here's Donkey, which was actually authored by Bill Gates, and it used it flipped the background color from black to this dark gray. Or sometimes here in King's Quest they in the CGA mode would use blue, because then they could kind of get a dithered thing, although it looks really terrible. And then of course there were some games that used 640 by 200, and then you get a single color. You can vary weirdly not the background color but the foreground color in this mode, and so it can be any of the 16 colors. There were a number of games that would use text mode, because at least there you could get an interesting range of colors, and some that would even use the 40 by 25 mode. It was a weird card. It had a bunch of issues. Obviously, there's the limited weird set of color. The text was low res and low res enough that people sort of, even in that era, found it sort of annoying, at least in the business setting. It had a non-square pixel ratio, although at least it was sort of in the right ballpark for the 320 by 200 mode. But the most peculiar issue was that it had this issue called snow, and so in all but the 40 by 25 mode, they had not wanted to have to slow down the main CPU in order to be able to avoid contention, and the RAM on the video card was not dual ported, and so if you happen to access the RAM during the time when it was needed by the display, you were in contention with the graphics card, and the CPU would be allowed to win, and so the graphics card would end up getting junk, and so you would get sort of this visible snow if you didn't either wait for the right moment during a refresh to write to the display, or use the one text mode that could avoid it. And unfortunately, there was no interrupt for the vertical and horizontal refresh, and so the only way to find out the status of it was by polling, which was particularly terrible. I actually had trouble finding a picture on the internet of the snow effect. It's sort of the best I could find was this a screenshot from somebody actually on a monochrome monitor, but this would happen on color monitors as well, and you would get this sort of cascade of all of the moments when the CPU was doing something. And this would come up even in the text mode, which was quite annoying. There were various workarounds where you could try to sit there and pull at least until the horizontal refresh, and then squeeze in a few characters. But it's an annoying sort of secondary aspect of this card. People did get creative. There were a handful of games. This is California Games, which is, as far as I know, one of the few that did an interesting trick. They would actually toggle the palette mid display refresh, and so they would typically have like a fixed background for the upper portion of the different scenes in the game, and that, because it was fixed, it would allow them to sort of sit there in a tight loop and pull the vertical refresh and count how far down the display they were, so that they could then flip the palette when they got to a certain line. So you're seeing sort of the upper half of the screen has one palette, and then the bottom half has another palette. And so this was a careful trick and hinged on sort of all the action happening on the bottom half of the screen, so that they didn't have to interleave this with the actual drawing code and so on. There were some alternatives. At the same time that CGA was sold, there was also the monochrome display adapter. This offered only an 80 by 25 text mode with there was an intensity bit. It was popular actually because it had a higher resolution text character, and so if you were going to stare at text on one of these screens for a long time, that little bit of extra fidelity in the shape of the characters mattered. Only 4K memory with it. Its lack of graphics, though, is sort of pointed in enough that one of the first third-party adapters for the card was a thing called the Hercules card, and I remember encountering this as well. It offered a 1-bit bitmap mode and actually fairly generous memory, two pages of memory, and then the other interesting option that probably informs why the sort of terrible colors in this display adapter were not considered as much of a problem at the time is that there was also artifact color. And so Artifact color is the idea that if you attach this device to a TV, and recall that it had a composite output as well as the RGB output, as long as you had the color burst signal coming out in each row, the TV would interpret that intensity changes at high enough frequencies as color signals. And so this is the same approach that was used in the Apple II, and in particular, it's very similar to what happens in the double high-res mode in the Apple II. And it allows you to get a sort of a quasi 160 by 216 color mode. And so, especially early on, when sort of the only monitors were from IBM and were super expensive, this was used by a number of games. And so you'd put out something typically in the 640 by 200 mode, and it would be interpreted by a TV as color. This would be, of course, glaring and unpleasant if you were actually trying to display text in one of these modes, because something with the bit pattern on the left would look like something like this on the right. And there are actually all sorts of tricks that you can play with this, and I'm not going to go into it because it's someone else's work, and it's actually builds on some of the things I'll talk about in this talk. But there are folks that in sort of the current day and age who have gone very deep in terms of pushing the limits of what you can do, and using some of the tricks I'll talk about here to get some interesting results with composite output. So this is sort of zoomed in. You can see sort of the fringing, and this again happens because you're emitting a signal that's faster than the color clock, which sort of ticks along. So folks did use it for games, and here's what King's Quest looked like if you attached it to a composite monitor and had it in the right mode on for the output, which is a pretty good comparison. You'll notice that the color palette is a little different versus what you would get, say, on EGA, because it's not RGB values, but is wherever you happen to fall in the composite TV color space. Actually, I'm sorry, the slide I thought was coming about the someone else's work is coming still, so that probably made no sense. So if you look at the cards of the era, this is what their memory map looked like. So there was typically, you had the bottom 640K available for contiguous blocks of RAM, and then up at in the B range is where the monochrome adapter was placed, and the Hercules card reused the same range and actually had the option to either emulate the monochrome card or it could squeeze all the way down into the same range of the CGA, and this allowed for some amount of attempts at compatibility with CGA. So you could try to use the Hercules card with various compatibility ops. But CGA fell squarely at B800 in that segment range, and it actually, on an actual CGA card, it doesn't bother to decode one of the bits, and so it will actually have a mirror of the same address down below. And this was something, that was, if you notice the overlap here, one common or sort of an interesting thing that you could do in the era was that if you had both the monochrome card and the CGA card, you could put them in the same system. So this is one of the first cases of being able to put multiple monitors attached to a thing, but you had to have one of them be monochrome and one of them be a CGA or later an EGA or VGA. And some folks would apparently use this to attach a debugger and so on, and have that along the side. That register or that output port that I was poking is actually called the mode control register, and it's got a bunch of bits, and it is actually the primary register that you would use to switch video modes. And there's a toggle for whether you have intensity, which is the bit that was intended to be toggled by that option that I stumbled into yay when I was but a lad. And then there's a bit to toggle the high-res mode. There's an option to toggle the display off, and actually in the BIOS code, when you're switching modes to avoid sort of thrashing and sending random signals to the monitor, you're supposed to sort of turn off the video, switch the modes, and switch all the settings, and then turn back on the video. And then there's a toggle that decides whether or not a color burst is emitted to the composite signal, but it actually also has some weird effects as we'll see on the palette. That's actually how you get those mode 5 red and cyan colors. And then there's a toggle for for being in graphics mode at all, and then a toggle for high res or low res in the text mode. And so if you look at all the sort of bit patterns that are used by the BIOS modes, there are these numbered modes. They don't match the modes in BASIC, weirdly. In BASIC, it's mode 0 is the text mode, and then modes 1 and 2 are the graphics modes. But in the BIOS routines, it's actually 5 and 6 that are the graphics modes, and then they have a separate mode for each of the different text modes. And and there's actually the two different modes, mode 4 for the 4 palettes, and then but if you look at this bit range, you're not using all the bit patterns. And so if you splay this out and you look at like what do these different settings do, it turns out that there are a couple of things hidden away. One is that there's some duplicates for the text modes that will ignore some of the bits when you're in text mode, and so there's some duplicates here. And then there's this mode that is identical to the 640 by 200 graphics mode, except that it has the color burst turned on, and so that's the mode that's actually being used for that composite. But where in here is my mystery mode that I stumbled into? It's not directly caused by this mode setting, despite the name mode control. So let's look at some of the other registers. Well, there's a color select register, and this is the one that lets you pick the mode for the color for the background in the graphics modes. It lets you pick the intensity of the palette and toggle between the two different palettes. So that's interesting, but that's not it. There's a status register that you can read from, and this is actually the one that you would use to if you wanted to monitor the horizontal and vertical retrace and try to adapt to it. There's also toggles in here for a light pen, and I my entire life I've never, other than if you count the Nintendo gun, I've never actually encountered an actual light pen. It's one of these sort of interesting things that surprise. You always see the hardware descriptions for light pens, but I've never actually encountered one. But there's a bunch of reading that can happen in this register for that. And then there's actually two other registers that are used as a pair, and actually I forgot to put a slide for those in here. Whoops. That are accessed actually with a pair of registers, and so these are actually the registers on the Motorola 6845. And so you set the register number in one of the registers, and then you set the value you can read and write in a second register. And there's a whole bunch of these because these are sort of particular to this generic component. And so some of them do things like set the number of characters in the horizontal range, because the thing needs to know how far over it's going in characters. How many of them are displayed? You can actually clip off the side of what's displayed, and then you can pick when the horizontal sync happens, and that needs to be just so if you want to actually align with the expectations of some of the monitors. And the same thing in the vertical direction. Although one of these sets how many character rows you go down, and I've got it highlighted here because as we'll talk about in a second, this is actually relevant. And then there's a toggle for interlace mode, which actually apparently weirdly doesn't do anything. It was some vestigial thing that it wasn't hooked up, at least on the CGA card. And then there is an option for the max scan lines addressed. And as it happens, when you are in the graphics modes, this will actually get set to the value 1. And what this does in the graphics modes is it allows the interleaving that happens. And if you look at the low-level mapping for how the graphics modes work, every other row is shifted 8 kilobytes forward in memory. And so you've got alternating rows at every 8 kilobytes. And for the graphics modes, this needs to be set to 1. But what happens is that if you change this register in the text modes, what this will do is it will decide how many of the rows of the character shape will be displayed, and it will proceed on to the next character immediately. And so if you set this to a 0, it will display only one row. If you set this to a 1, it will display 2 rows, and 3, it will display 4 rows, and so on, up to 8. Actually, you can go I believe up to 31 because of the way the hardware works. And but it'll display nothing after you get beyond row 8. Except if you have the cursor. The cursor is actually capable of going all the way up to 31 rows. And so it turns out that what I had done when I was doing that out operation is that because this register was set to a 1, register 9, when I was in graphics mode, and I unceremoniously put it back into text mode, I had put it into a mode in which the upper 2 characters, or upper 2 rows of the characters of the text mode were being displayed. And at the time, and then also because in the graphics mode, this vertical displayed register needs to be set to 100 because there are 100 rows that alternate between those two upper and lower banks. I was getting a full, not 25 rows of text, but actually 100 rows of text. And so this unlocked this interesting mode in which you get the upper 2 characters of things. And there are some additional registers in the Motorola chip that control things like there's a cursor that can move around and you can set its blink rate. You can actually shift what portion of the buffer it uses. And so if you're willing to do some very crude operations with chunked 1 byte at a time, you can actually do scrolling. Although because there's only 16 kilobytes of memory, there's not a lot of room to work with in the graphics modes. You could use it in the character modes, but that sort of isn't all that useful. And then there's stuff for the light pen. And so it turns out that in this mode, you get 2 rows per 2 rows of each of the characters. And on this card, you're not allowed to change the character set. The character set is baked into the ROM. It's not an adjustable character set. It is on some of on EGA and VGA, but on CGA, you're stuck with the ROM character set. But if you go looking through the character set, there's a couple of characters that have a solid value on one side of the character and an empty value on the opposite side. And so using a grid of that character, you can actually create a 160 by 100 graphics mode in which you use the foreground and the background to specify. And there were a handful of games, including this Pac-Man clone, that used it. It's a fairly chunky mode, but there it is. And so this is here's sort of a look at what's actually happening. If you look at the table on the right, at each of the character positions, you're getting just those top 2 rows of the character. And so you can, if you're willing to be very creative, attempt to use this mode as sort of what this website calls the ANSI from hell, where you're dealing with these unusual ANSI characters where you're getting just the tops of the character, and you're sort of cleverly intermixing it to get interesting pictorial results. And I think one of the reasons that this experience stuck with me as a kid is that even at 9 or so, it dawned on me that, boy, this would be really useful if you could use this, that you were getting the tops of the characters, and if you could draw in this would give you a lot more color and would be a pretty interesting mode. And so a handful of games in the era did use it. There's 7 Spirits of Ra, which sort of worked around the limitations of the mode, and on a CGA, or our monitor will actually give you 16 colors. And so, I filed that away in my head as, well, that was interesting, but as I didn't have access to the hardware, I didn't think much more of it. This is the thing I was mentioning earlier. I won't go into this. There are some folks online that in our contemporary era have combined this mode from hell with composite and are able to actually get an amazing range of colors out of out of the thing on CGA. They do this by basically combining the dithering effects that you can get in this mode with the fact that you on composite you get further fringing that will happen, and so they're able to squeeze 1024 colors out of this. They also end up having to do some additional things like watch for that retrace and toggle some of the addresses in the memory as they go to get even more resolution out of it vertically. But I've held this memory of, gosh, wouldn't it have been great to be able to use that mode? And so I had always filed this away as something interesting that I wished at the time I had the sort of full technical wherewithal to fix. And so I thought, well, let me go back and look. And so I was curious, how well does this ANSI from hell work? And so I wrote some code to take each of the 65,536 different shapes and color options and just sort of brute force find the best fit for an image. And I tried this in Python, and Python was too slow, so I rewrote it in C. I could have tried Forth, but at the point that it was too slow in Python, I thought, well, let me do it in C, because I was waiting 20 minutes for one image. And so let me show you some results from that just to give you a sense of what this mode can do. So I took a bunch of old games from that era, and then what I did is I brute force tried to use this is the EGA version of the game, so 320 by 200, 16 colors, and so I brute force tried to match it and sort of get the best match that I could get. And so it's not great, but it's not too bad considering this is the difference between a card that really was meant to do 16 colors and one that was not. And so here's several of these. Here's one from Indiana Jones, and that's not too bad. You can see sort of a little bit of the chunkiness of it. So it's interesting because the mode that you're targeting is actually a 640 by 200 mode, but very limited in terms of what you can do with the character sets. So some of these, especially on sort of the low fidelity, the monitors of the era, might have been passable. And this is, mind you, just sort of brute forcing it, and so it's kind of doing sort of a perceptual diff distance. And so, not too bad. Some of them doesn't do great on text. There's actually one website I found where somebody went through the exercise of if you were trying to do text, you can actually find sort of better fits. I think one problem here is it's happy to sort of mix in grayscale and sort of do that, which is maybe okay for an image, but doesn't look so good for text. I tried it on this 256 color image, and it did very poorly. So it's not that flexible. Here's Loom. This one's pretty good. And it's interesting how, even with some of these dither patterns, it's able to sort of preserve some of the flavor of it. Here's some Monkey Island. So it probably would have been a usable mode in the era, except for the fact that it's really challenging to find these fits. Here's one that's in 640 by 200, and it's sort of okay. Anyways, here's another 640 by 200 one that doesn't look that good even in the original EGA, in all honesty. Here's one I actually had it scaled down, and then I thought, boy, that looks particularly chunky, and then I scaled it up, and it's a little bit better when it's aligned to the grid. This is the problem of it being sort of interpolating on the edges at the wrong resolution. So. So how about doing this in real time? Because this is an interesting mode, but to be able to do it real time would have been the thing I would have wanted at the time. And so let's see if we can run some actual DOS code that can use this mode and work around the funny limitations. So for that, I'm going to use Pygmy Forth, and Pygmy Forth actually happens to be the very first Forth that I actually encountered. It was created by Frank Sargent. It targets DOS. It uses a tiny memory model, but actually kind of does some uses extra memory on the side for things like buffers. It uses blocks extensively, but supports files. It's got an assembler and screen block editor built in. It's got a meta compiler. And as I said, it was my first forth. So I actually initially started using the block editor in the thing to create some of the code that I used here, but I ended up caving and putting it into a source file because I'm too addicted to VI. So I added a random number generator because I was going to need that. I added some code to switch the BIOS modes and switch into the different modes there. And then I added some code for manipulating those registers that we talked about earlier. So the manipulating the different CGA registers. And in particular here, there's this graph 16 mode, which goes ahead and uses the BIOS to put it into text mode, and then sets up the 2 character lines, and then sets the number of rows to 100. By the way, you might be curious. Actually, we'll talk about that. Never mind. I'll talk about that when we do the demo. And then one of the things actually in the pictures that I generated earlier, I actually saved them in a format that's actually used by BASIC. There's this bload format that has a 7-byte header that we'll see in the demo. But I did some forth code to be able to load that. And then what I decided to do, because another thing I remember from this area was sort of being befuddled by how challenging, at least at the time, I found it to manipulate the graphics memory. So I thought, well, let's try to actually do a generic graphics library that supports all these different CGA modes. So I set this up with a variable to hold the width and the height. I actually use a pattern, so for some of the modes, I actually don't end up doing this for all the modes, but for some of them, I'm able to support not just a single color, but actually doing a stippling pattern. And then I defer the word plot, and then I have a word that will fill in a row built on top of plot, and then a word that will draw a box. So then these routines end up being generic, and so then I provide an implementation for each of the modes, and so. Here's the implementation for that 160 by 116 color mode, the sort of like the Paku Paku game used. So I set in this 160 by 100, I switch into the graphics mode, I clear the display, I set up plot 1 as the implementation of plot for the mode, and then set up the width and the height. And then plot 1 needs to make some decisions based on whether you're on an even row or an odd row or an even column or an odd column. And I dispatch this through a jump table just for efficiency, and then have slightly different versions of each of the words. Probably could refactor this. There's a lot of redundancy in it, but this was sort of done in a quick go. And then something similar for the 320 by 200 4-color mode. I switch into the mode just using the BIOS, blank out the screen, and then here there's only a 2-way switch for whether you're on an even row or an odd row. But I do have a little bit of extra masking that's in there to work with the patterns, and we'll see in the demo what that does. And then almost identical, you'll notice the 320 by 200 and the 640 by 200 are almost identical because it's just the difference of single bit versus 2 bits. And then what about that direct CGA mode, the sort of ANSI from hell? Well, what I figure I need to do is I need to know the shape of each of the characters, and then I need to, every time I access a pixel, replace the least used color when adding a color in the 8x2 character grid. And then because each 8x2 character cell can only have 2 colors in it, you're going to get a thing called attribute clash, which typically, you'll see on systems where they can redefine the character set and you have like an 8x8 block. But I'm going to just ignore it because especially for an 8x2 character, like there's not a lot of pixels in there. And then what I want to do is pick a character with a reverse mapping for just the 2x2 area that matches. And so what this means is I'm effectively ignoring the fact that you could get all the way to in principle to 640 by 200 and just focusing on achieving a 160 by 200 mode, because at least that way there's a reverse mapping. So reading out the BIOS, I actually, interestingly, there is a particular spot in the BIOS that's well known to have the lower half of the the character set. And remember that the on CGA the character ROM is actually attached to the CGA card, is not addressable, and so they had to actually include a second copy of the character set in the BIOS to expose it for drawing characters when you're in those graphics modes. And at least initially, they didn't include the upper set, and they actually sort of defer this, and only in larger ROM sizes they include it. And they actually use weirdly one of the interrupt tables entries to be the address of where to put this copy of the upper half of the character set. And then because I'm working with this ANSI from hell, what I did was I just and I actually, sorry, I'm showing this, but I didn't actually use it, because what I ended up doing is saying, well, let me just pick 16 of the characters, or actually rather 8 of the characters with their reverse video complements, where they're approximately forming a 2x2 grid. And so I picked a few of the characters where the upper, if you just look at the upper row of these characters, they end up being approximately what you would need. And these are the best fit I could find. I did a little bit of code to try to search for them, but ultimately I ended up picking them by eye. And then I create a table of them, and then I create a reverse table, and then I also have a word to do a nibble swap, because I need that if you find that you're about to use a color and you're going to use it. And this and so then the code for this mode is a little bit bigger. There's a word to decode the address and fill it in and do the nibble swap depending on what color. There's a mode that deals with the case where you're writing in the foreground color versus the background color, and then in the plot word you have to deal with each of the cases. So you have to find the address you're at, decide if one of the existing colors is a color you're drawing in, and then use that if it's the foreground color, if it's the background color, and then if neither of those works, then I do a population count to decide which color should I kick out, and then draw in either the foreground or the background color, and then glue it in as before into a mode. So a lot of steps, but as we'll see in the demo, it at least does something. So I'm going to flip over to the demo. I'm going to kill that window and fire up a different window. So for the demos, I'm going to use an emulator called DOSBox, because as it happens, I don't actually have a CGA card. But DOSBox does a pretty good job of actually emulating even some of these CGA modes. It actually is able to emulate some, but not all, of the artifact color. It does not emulate snow, although there's a guy out there that has a patch that will do that. I actually have my code loaded in a source file, and I've got a little batch file that loads it up. So I'm going to just fire up and show the demos. And then maybe I'll go back and show some code. So this is Pygmy 4th.
You have about 10 more minutes, Brad. Okay,
that's about all I'll need. So this is Pygmy 4th, and what one of the neat things about it is that it has this memory mapping of files into blocks. And so you'll see here that like the Pygmy 4th source code is mapped at block 0, and there's actually, you can go in and there's a block editor, and you can span forward, and I actually, as I was poking through here, it was amusing. I actually came across, there's a reference to Dr. Ting in here, and one of the words, I'm probably going to struggle to find it here, but that he uses one of Dr. Yeah, there it is. He uses Dr. Ting's approach to digit handling and mentions it. So in any event, let's check out the modes. So one thing is I've got a word here that will load one of those pre-canned images and just switch into the mode. And so there it is. It's one of those C code converted images, but that's not much fun. Now I've got a test word that goes through and actually draws in each of the graphics modes in the order that we talked about them earlier. So here it's drawing with a stipple pattern in that 160 by 100 mode, the mode that Paku used. And then here it is in 320 by 200, the 4-color mode with this sort of, actually, this is the least ugly of the palettes. It's not too bad, especially when you add in stipples. Here's the monochrome mode. And then last, I've got my 160 by 200 mode. And you'll notice there's a little bit of artifacts on the edges because it's not a perfect fit in that mode, but not too bad. But so I won't look at the code for this, but I've got some code for mouse handling. And so what I've got here is a little drawing program that uses the, oops, that's the wrong one. That uses the, oh, actually that does demonstrate the mode. And so you'll see that it's a little chunky, especially when it's a single pixel. But it is what it is. It's sort of, as it was said, ANSI from hell. And here's that graphics mode. So this is actually drawing a 3x3 area, and you can draw in it and get pretty good. And each time I draw, it picks a different color. And here it is on CGA, more than 4 colors, which is, whoops, and it's picking the same number because my random number generator is not that great. And I've put up the source code online if folks are interested in the innards. The mouse handling code is a whole separate thing. Here's the same thing, but with a, oops, that's single pixel. I meant to do this one. Here's a single pixel. You can see it's a little bit junky. And with that, are there questions?
Don, don't go anywhere. We're going to be done in 5 minutes. So,
Brad,
okay.
I just make a couple of comments on those days. I think the thing, I was working on a Sage Desktop 68,000 with RS-232 connection to an HDS APL terminal, which had like 4 pages of memory in it. But to me, one of the things that made the revolution, if you will, to the PC was the tightly coupled display, as opposed to having this RS-232 interface, which everything else did. I mean, there were tons of 68,000s, and the linear address, a 24-bit linear address space just made it perfect for, and I was doing bitmap graphics and so forth. But one of the other things when forced to the inferior but marketable PCs, something that I really appreciated was the ability to make my own bitmap character sets, because I used I just made a character set where the minuscules were the same as the maxuscule, whatever. The lowercase was the same as the uppercase, except, if you will, squished, so that looking at a global audience, you only had one character set to learn. It's not like so many languages have actually, and definitely little a versus big A, you've got these multiple character sets, and Japanese is lousy for that. They got like 3 different sets of.
It was a real tragedy with the CGA card. They didn't let you redefine the character set for a lot of the systems of that era. That was sort of a useful thing in the text mode, but
it's something I really miss, because I like extreme simplicity, and to go and make my own character set where hey, you only got one damn character set. But I think it's an interesting thing that humans like having an upper and lower case as much as they do. I mean, it seems like such a crazy little binary,
Yeah, I think for me, the other thing that was jarring about seeing that CGA system was my first experience with computing was with the TI-99 4A. So it was going from this system with color and whatnot to this kind of limited, boring system. It was odd. It was like nice to be able to plot a circle, but terrible that it had such lousy colors.
So we ran out of time to squeeze in Chris's talk. Brad, if I may write an end to you for just a few seconds and give Chris an opportunity to tout his talk for next month.
Apologies for going so long, by the way. I think I misgauged the timing.
It's fine. We enjoyed the content. Those were the days. I wanted to say that there was after the CGA, there was a PGA, and the Saudis bought it by mistake. But we digress. Chris, you're on.
So I'm trying to figure out what to do for a master's thesis, and I've been looking at all the different fourth processors, so I wanted to talk about them. A lot of the J1 families very heavily used. And in particular, I want to do like 8 of them or something. And so I have big questions about how do you get memory with that you can divide up into 8 blocks of memory, like on an FPGA, and particularly on external memory, like on the board, the core one that they're building. Do I have 8 different accesses to the external memory or just one? Will there be conflicts? So anyhow, that's kind of where I'm at. Thank you.
That sounds really interesting, and I'm sorry we weren't able to squeeze it in this month.
No
I'm
worries.
looking forward to it.
We're
Brad,
gonna-
be sure
Very
to
sorry
put
about
your,
that, Chris. I should have timed my talk better.
I did the
timed
same
your
thing,
talk just
Brad,
fine.
so don't-
Be sure
and so
to
we're-
send Dave a link to your code for the meeting notes. Brad,
Will do.
acknowledge. Over.
Yeah, Brad, I want to rename this video, so I'll send you an email with that. And Chris, we're going to go into open format so we can answer a lot of your questions for your paper.
Awesome. I'll put the link in the chat if anyone wants to scan through the slides.
So we have a ceremony to start the recorder, and we unceremoniously end the recording. So it's that time. Brad, would you